So last week we focused on the graph of sine functions. This week we're going to focus on the graphs of cosine functions. The parent function of all cosine functions is y is equal to the cosine of theta, or y is equal to the cosine of x. So we're going to be graphing cosine equations or cosine functions given an equation in the form of y is equal to a times the cosine of bx. So a, again, the absolute value of a, just like with our sine functions, is going to represent the amplitude of the function. B will then also still represent the number of cycles between 0 and 2 pi. So how many times does the cycle of this cosine function occur between 0 and 2 pi? And then 2 pi over b is just the algebraic way of finding the period of the function. So 2 pi over b is the period of the function. And I just misspelled period. The period of the function. There we go. Okay. So a lot of things are similar in the way our equation is set up for how we're going to graph these cosine functions, which is handy. It's similar to our sine functions. However, when we did our sine functions, when we graphed them, we knew we would have a 0, a minimum, or a maximum. I think it's usually a max, right? Followed by another 0, followed by a minimum or a maximum, and then followed by another 0. Well, for cosine functions, that's going to change a little bit. So cosine functions actually start with their maximum or minimum, then they go to a 0, then they go to a minimum or a maximum, depending on whether or not it's being reflected over the x-axis. Then it goes to another 0, and then back to a maximum. So this would change if it was being reflected over the x-axis. It would start with a minimum, 0, then a maximum, 0, then a minimum. So we're going to look for these 5 points to help us graph. All right, so in example 1, we need to graph y is equal to 1/2 times the cosine of 2x. So as you can see, our a is equal to 1/2, and our b is equal to 2. So that means that our amplitude is 1/2. And then we have b is the number of cycles that occur between 0 and 2 pi. So this tells me that 2 cycles of this function occur between 0 and 2 pi. So to find the period of the function, we would have the period is equal to 2 pi divided by b, and in our case, b is 2. So the period is equal to 2 pi divided by 2 is simply pi. That means that our function has one complete cycle between 0 and pi. And we only have to graph one cycle. So once we find one cycle, we're done. Okay, so I know I'm going to start with a maximum, then a 0, then a minimum, then a 0, and then end with a maximum. Well, my maximum is at the same y value as my amplitude. So if my amplitude is 1/2, that means my maximum is going to be at 1/2. So this would be 1, this would be 1/2. So my maximum occurs at 1/2, or 0.5. Then down here, this would be -1. So this would be positive 0.5. Okay, negative 0.5, sorry. So then From there, I'm going to end on another maximum. And I know two cycles occur between 0 and 2 pi, so my period is 0 to pi, which means my other maximum has to occur at pi. Then halfway between those 2 points, we're going to have our third point. So we graphed one of our maximums, we graphed our last maximum. Halfway between them, we're going to have our minimum. And our minimum's also going to occur at the same distance as the amplitude, or negative 0.5. And obviously our midline is staying at the x-axis here. Then halfway between these 2 points, this maximum and this minimum, we are going to have our 0. So halfway between there would be here, and that's going to be 0. Then halfway between these 2 points, we have a 0. And there we've graphed a complete cycle. We're going to sketch in the curve. This curve is terrible, and I apologize. I'll use a highlighter. And there's our curve. Now we can move on to example 2. So for example 2, you're going to do the same thing. You're going to identify your A and your B. So you're going to tell me what your amplitude is. You're going to tell me what B is, and then you're going to find the period of the function. And then you're going to graph your maximum, then a 0, then a minimum, a 0, and a maximum. So why don't you press pause on the video, go ahead and try it on your own, and then check back with me when you're done. So we only have to graph one cycle. Our amplitude is A, which is 3. Our B is pi over 2, which means that our period is 2 pi over B, which is 2 pi over 2. So 2 pi divided by pi over 2, or 2 pi times 2 over pi, so 4. So our period is 4. That means that from 0 to 4, we have one complete cycle. Well, where's 4 at on this graph? Well, if pi is 3.141, and let's see, 2 pi is 6.283. 4 has to occur somewhere between these two, right? So what value would be halfway between them? Let's see, minus 3.141. I'm just taking this 6.283 minus 3.141. And of course that's pi. That was ridiculous. Divide it by 2, then add it to 3.141, and we get 4.71. So 4.71. Okay, so then halfway between 3.141 and 4.71, so I'm just going to subtract those two. Divide it by 2, and then add it back to 3.141. That gives me 3.9. So this would be 3.9. So 4 is basically here. This is 4. And we're clearly estimating that a little bit, and I'm okay with that, no worries. So let's graph our maximums. Oops, that was supposed to be an eraser. All right, so my maximum is occurring at an amplitude of 3. 3 would be here. And then I end with a maximum. Then halfway between 0 and 4 would be 2. And so my minimum occurs at the x value of 2 and then negative 3. So I just need to figure out where 2 is here. Well, what's halfway between 0 and pi? Let's see, pi divided by 2 is 1.571. Then halfway between that and pi pi minus 1.571 divided by 2 plus 1.571 is 2.35. So 2 is about here, we'll say. So then our minimum is happening at 2, -3. And then we have to have a 0 halfway between these 2 points and halfway between these 2 points. So I'm just going to estimate that, and I'm going to say that halfway between 2 and 4 is 3. If that's 3.1, 3 would be about here. Then halfway between 0 and 2 is 1. 1's going to be about there. And I'm going to use my highlighter, and I'm going to sketch in that curve. And there we go. We have one cycle of this particular cosine function.